will go to the next experiment in cycle 1. Okay, so that is amplitude shift keying, detection, generation and detection. Okay, so we are going to do this experiment using SL100 transistor as a switch. Okay, this is a circuit for amplitude shift keying, which will be connected with the base is connected with the binary, which is taken NRZ signal of +5 and -5 volts. So that is 10 volts peak to peak, and in the collector we have connected we have taken 1:4 ratio of 250 hertz modulating or binary and 1 kilohertz sine wave carrier. Okay, so two signal, one is the modulating signal, which is a 250 hertz square wave, which is a NRZ, that is +5 volts is the binary 1 and the -5 is binary 0. And in the carrier, the collector, we have taken the carrier. So this transistor is connected as a emitter follower, that is common collector. So emitter follower is a circuit where the output is taken from the emitter, output is collected from the emitter, and we have not given any DC supply here, with the amplitude from the base, that is binary input, and also the transistor will be switched on, that is in the saturation condition, switched off in the cutoff condition. So two levels we are taking here as a switch, one is in saturation, the other is in cutoff condition. So whenever you have a binary signal which is +5 volts, then the transistor will be in saturation or it is in on condition. When it is on, we know that the collector current is approximately equal to the emitter current. So all the signal which is connected in the collector, which is a carrier of 1 kilohertz, it will appear in the emitter. So this will appear as long as the binary which is given for a duration, it will be on. Since we have taken 250 hertz here, as per the time scale 2 milliseconds time duration, the carrier will appear at the output. Once the binary signal will go into the negative or -5 volts or binary 0, then the transistor will be in switch off condition. So when the transistor is off, the current is 0, so no signal will appear at the output of the emitter. So you will get alternate depending on what is the signal 1 and 0, 1 and 0, you will get ASK signal, amplitude shift keying, amplitude of the carrier is shifted according to the modulating binary signal. So I will show you the same with the experimental setup. So here, as per the circuit diagram, we have two signals. The one is the square wave signal, the other is the sinusoidal carrier signal. So here, this is the carrier signal which I am showing. The circuit is already connected with okay, channel 1 and channel 2 I am showing you here. This is channel 1 and
no, handle is channel 1.
Channel 1. Okay. So it is connected with, this is connected with the square wave signal, which is of 250 hertz. You can see the signal here. So the frequency is given
last slide.
Okay, 254 hertz. Okay, this is your modulating binary signal with peak to peak 10 volts or +5 and -5. Okay, so I'll show you the carrier signal here, which is a sine wave connecting it to the other channel. Okay, this is in the collector of the transistor, so which is
stop. Stop. Stop.
Okay.
Measure.
So you have here the signal
measure.
which is given in both the channels. Okay, one is the binary signal which is of 254 hertz, and the carrier which is taken around 1K, you are getting here 1.15. Okay, so this is the high frequency carrier, the high frequency ratio is 1:4. Okay, now I'll show you the ASK signal, which is okay. I'm checking the output at the emitter. Okay. So whenever, as per the definition of ASK, whenever you have a modulating or binary signal, amplitude is 1 or logic 0, the carrier should appear for a duration as long as you get a binary 1. So this is a duration of approximately 2 milliseconds, and when the modulating signal binary input is 0, then output will be 0. So this is your ASK signal. Alternately you are getting here, whenever the binary is 1 or modulating signal is high, carrier signal will appear. Whenever binary or modulating signal is low, it will be 0 since the transistor is in switch off condition. And this is your ASK signal, which is having amplitude of approximately 6 ohms. Okay. Now we will see the demodulation. So for demodulation, we are using the envelope detector. So why the envelope detector? Here we are checking the amplitude shift keying. So you have to recover back the message signal which you have given. Okay. So for that we are taking here the envelope detector circuit. So envelope detector is nothing but we are using a diode here. So BY127. So this is a diode which removes the positive half of the signal which we are applying as an input ASK, and RC, which is a filter which removes the ripple. So we have taken this RC time constant as per the design which we have discussed. So as the time constant is more, the discharge time will be reduced, so you will get the recovered signal very quickly. So here is the both together, the diode and the RC network which is acting like a filter, will call as a envelope detector. So at the output of the envelope detector, you will get a charging and discharging waveform with certain amplitude. So to recover back the original message signal which we have given, since we have given a NRZ data, or the +5 is a positive logic and the -5 is 0. So to get back that one, we are using a comparator circuit here, op-amp as a comparator. So here output of the envelope detector will be given at pin number 3. This is a non-inverting op-amp circuit as a comparator. So output from the envelope detector is given as an input to pin number 3, which is a positive. So here to the pin number 2 or the inverting pin, we are applying a small bias here from the supply. So by controlling the bias signal, we can get the recovered message signal. So here when the envelope output is high, we can adjust the bias approximately half of the envelope what we are getting. So that will be comparing and you will get back your recovered signal. And since we are using a comparator, the amplitude which we will get at the output of the envelope detector and the comparator circuit will be high, since we are giving +12 and -12. So we get a saturation levels approximately 90% of the supply voltage. So frequency will remain the same as we have given 250 Hz. So I'll show you the demodulation circuit stage wise. Okay. So I'm connecting at the input to the envelope detector, output of the envelope detector, input to the comparator. After the diode, okay, this is after the diode. You can this is the diode which is the modulated signal which we have given. It is a IN4001, and this is the output of the diode along with the filter. This is R and C which we have connected here. So I am showing you the envelope detector output. Okay, so this is your envelope detector output, which will have only the charging and the discharging. Output of the diode is connected to the envelope detector circuit. Okay, I am connecting here the envelope detector. You can see the waveform. So this is the charging and discharging waveform. So whenever signal is there, you are getting a charging and discharging. Okay, and when signal is not there, you are getting a 0 signal. So this signal is applied as a input to the comparator. Okay, so input to the comparator is pin number 3 here. Okay, same signal you will get here, pin number 3. Okay, this is the same signal you are getting at pin number 3 also, same charging discharging. So I will show you at pin number 6.
Next.
Pin number 6 is the output. Okay, so you are getting recovered message signal.
Position correct madam. ಮೇಲೆ ಅದು
Okay. small adjustment in the bias you can do to get the recovered waveform. Since it is a comparator, it compares with the bias changes. Okay, so small delay will be there. So you are getting the same frequency. You can observe here 231 and with a voltage of 21.8 peak to peak. Since we are using a comparator of 12 volts and minus 12, so approximately 90% of the signal will be given as a plus and minus V saturation. So it is equivalent to what we have given as a binary input. So this is the detection of the ASK, which is having the same frequency, approximately the same frequency with changing amplitude. Okay. This is the ASK generation and detection using the transistor and envelope